It's useful to be able to have input from the user and to print output to the screen, but it's also really useful to have file input and output. There are several functions in MATLAB that do this for us. We're going to start with the simple ones, which are called load and save. First of all, there are three modes or operations that you can have on files. One is you can read from a file, and then you can also write to a file, but that actually breaks down into two categories. You can do what's called writing to a file, which assumes that you're writing from the beginning of the file, or if you already have an existing file and you want to add to the end of it, you can append to the file. So that's also writing, but starting at the end. So again, there are three modes. You can read from a file, you can write to a file, meaning the beginning, or you can append to a file, meaning you write from the end of the file. There are some simple file input and output commands for saving a matrix to a file and also reading from a file into a matrix, which are called save and load. So again, save and load are very simple file input-output functions that only work with matrices. So if what you want to do is to read from or write something other than a matrix, you have to use different file input-output functions, which are called lower-level file I/O functions, and we'll get to that later on. So for now, just load and save. If you have a file that basically looks like a matrix, and you want to read it into a matrix variable, you use load for that. So what do I mean by looks like a matrix? Well, a matrix has the same kinds of values in every element, and it also has to have the same number of values in every row in the matrix. So if a file looks like that, for example, if it's a file of numbers and you have the same number of numbers in every line in the file, then you can read it into a matrix variable by saying load, and then the name of the file dot the extension on the file name. And what that does is that creates a matrix variable in MATLAB with the same name as the file, not the dot extension, but just the file name. So again, this can only be used if the file has the same number of values on every line, and then every line from the file is read into a row in the matrix variable. Now, if what you have is a matrix variable and you want to write that to a file, again, you can either write to a file or you can append. So the way that works is with save, you say save and the name of the file that you want to create when you're writing to it, the name of the matrix variable that you have, and then you have to put dash ASCII to make it an ASCII file. If you're appending, same thing, save, the name of the file, the name of the matrix variable, dash ASCII, and then also dash append. So that assumes that the file already exists. With scripts and input and output, here are some common pitfalls. One is spelling a variable name in different ways in different places in a script or a function. Another is forgetting to add the second argument, which is quote s quotes, to the input function when you want the user to enter a character or string input. Not using the correct conversion character when printing. So remember D for integers, F for float, C for character, S for strings. And confusing fprintf and disp. Disp just displays something, but it can't format. So remember that only fprintf can print formatted output. And not realizing that load will actually create a variable with the same name as the file, but again, not the extension. Here's some programming style guidelines. Always use comments to document your scripts and functions, to explain exactly what they're doing and how they're doing it. Use mnemonic identifier names. Use names that make sense. For example, radius if you're creating a radius of a circle rather than XYZ. That's true for both variable names and for file names. Put a new line character at the end of every string printed by an fprintf so that the next output, whatever that is going to be on the line below, and that could include the prompt from the command window. So you want whatever comes next to be on the next line and not on the same line. Put informative labels on the X and Y axes when you plot, and also a title on the top of the plot. And in scripts, always, always, always suppress all of the output from all assignment statements. So always put a semicolon at the end of every assignment statement in a script. You don't want to see the variable equals and then a value. You want to control what the output looks like by using fprintf statements.